Hello everyone, welcome on this video about object pooling in Unity. This video is aimed at people who already know a little bit about object pooling, who probably already have done their object pooling, and who want to go a step further. And what do I mean by a step further? Well, most tutorials will explain how to do object pooling for one type of object. But what happens when you want to add lots of different types of objects? You're gonna end up with lots of different object pools, and it's gonna clunk up a little bit everything. And what I want to do here is go with a more flexible system that actually has an object pools manager that will by itself create new object pools if necessary. And let's first see this in action. Here I have this little scene with a tree and cannons around the tree. And those cannons, they shoot different kinds of projectiles. This cannon here shoots a normal projectile. This one here shoots a projectile that is called a poolable projectile. And we'll see in a minute what the difference is. This one also does poolable projectiles, and this one does other poolable projectiles. So if we look at those little projectiles here, the main difference is that the poolable objects, they have a little poolable component. And that's what makes something poolable or not in my system. So if I fire my first cannon here, oops, I do need to do play. If I fire my first cannon, well, it shoots a projectile. You can see it coming from there. It shoots a projectile, and that projectile gets destroyed here by the tree. And we can see that it is instantiated here on the scene and gets destroyed, and it's removed. Now, if I shoot my second cannon here, that shoots poolable projectiles. Well, the cannon is going to shoot a poolable projectile that gets removed from the scene as well. But as you can see here, we have instantiated an object pools manager, and that object pools manager has a pool of poolable projectile. Now it has a little number in it. You'll understand later what it does. And currently this object has no siblings, but that's because the tree here is not using the pooling system yet. So now if I say, when you destroy an object, you can try and pool them. So I still shoot with my first cannon here. So that's a non-poolable object. It still gets instantiated, still gets destroyed. But if I shoot my poolable projectile from my cannon, now that poolable projectile is still on the scene. It's just disabled, but it's reused whenever I need one. And if I shoot a lot of projectiles, they all get reused later on. So now the number of projectiles I have on the scene, I just have a bunch of inactive ones. And if I shoot my other poolable projectile, it gets instantiated in another pool automatically. Everything happens automatically. So let's see how all of this works now. First of all, let's look at the poolable class. So the poolable class is a mono behavior. It has an int poolable ID that is hidden in the inspector because I don't want anyone to mess with that. I want actually to control this from my code and only from my code. And we'll see what it is about later. And it has a boolean that's called isPooled, and well, it's here, it's a private one. And it has a property that's called isPooled, and that returns isPooled if we call it. And then if we set it, we do two things. We set isPooled to the input value, but also we set the game object active state to the opposite, essentially. So if it's pooled, we want it to be disabled, and if it's not pooled, then we want it to be enabled. This can be customized if you want to do more stuff when you when you unpool your object. But yeah, that allows for more flexibility if you want. And then the last thing, and we'll talk about this a little bit later, but if for some reason our object gets destroyed by some other script, I don't know, it could happen, should not happen, but it could happen, then we just want to make sure that the object is removed from the object pool. So now let's look at our object pool. Object pool is a class. It's not a mono behavior, by the way. The reason why it's not a mono behavior is that mono behaviors, they take a lot of room in memory. There's a lot of extra stuff that comes with them, and we just don't need them for the object pool. So it is actually a little more efficient than having tons of different object pools as mono behaviors on your scene for all different objects you have. So it has a list of poolables. So we only allow to pool objects that are considered poolable. And also that specific object pool will have a specific prefab that it is going to pool. It's only going to pool instances of that specific prefab in that pool. And there is also a group, a transform. That transform is how we are going to put the pooled objects in the hierarchy. So next we have a constructor to create a new object pool. That object pool takes as input a prefab. That's going to be the prefab on which all the poolable objects in that object pool are going to be based, and the transform where all these instances are going to be parented. Next we have a get object. So if we need an object of a specific type, we ask the pool that's responsible for that type of prefab to spawn us an object. And to spawn it means one of two things. Either there is an object available in our list of pooled objects, then, well, we can just remove it from the pool and set its state to its pooled state to false. Note that I am not working here with the active or inactive status. That is all handled in the poolable. That's important to keep that really separate. So if I want to create new versions of poolable, I can actually make it more complex, no problem. And so then we remove it from the list, because objects in the list are always going to be objects that are available and only available objects to recycle. Then if the number of items is not greater than 0, it means that, well, we don't have any available items to give to whatever needs a poolable object. So we're going to instantiate a new instance of that prefab, and we're going to set its parent to our group. And then once that's done, we return the object. Now the other operation is the reverse operation, is if we want to pool an object, so add it to the pool. So instead of destroying our objects, we recycle them, and instead of destroying them, we put them in the pool. So we first check, hey, is the poolable ID, remember that's in our poolable thing here, there's poolable ID. If the poolable ID is the same as the poolable ID of our prefab. So this is how we recognize that, hey, you want to store an object in my pool. I want to be sure that it is actually made from the same prefab, and you will see how we enforce this later. So I have to check first, is it the same object as the objects I want to accept? And also, is it not already pooled? Because if it is already pooled, then I don't want to pool it a second time. If you pool an object multiple times, then it's going to be multiple times in the list, but it's still one object. So you would be messing around with its active status, and it would be a bit of a problem. So if it's not pooled, and if it is indeed the right object, then we add it to the pool, and we set its isPooled state to true. And then we just return true, so that whatever is calling our pool object thing knows, oh, okay, it worked. We could actually pool this. And if not, then it returns false. Then finally, there's this remove method we talked about earlier. So if for some reason my poolable object is destroyed by another object while it is inside of the pool, I want to make sure that it's no longer in the pool, so I remove it from the pool. That's the idea. So now let's see how we create the object pools and how we call them with our object pools manager. So the object pools manager is a singleton. If you don't know about the singleton pattern, you can look it up. If you're curious about how I implement singleton, we could go over it, but it's not the topic in this video. So object pools manager is a singleton of object pools manager. This means that there is only ever on the scene one and only one single instance of object pools manager. It has a dictionary that takes an int as a key, and that int is going to be that poolable ID which we talked about earlier. And to each poolable ID corresponds an object pool. So that's my that's my dictionary of pools, and I initialize it to an empty dictionary. And then here I have a get object method once again. So that's when we want a new object. So get object will take a prefab, and it will first check, hey, what's the poolable ID of that prefab? If it is 0, then it means that that prefab does not did not initialize yet its poolable ID. And we initialize it with the instance ID of the prefab. Instance ID is guaranteed to be unique. So we know that this prefab will have a unique ID that we will then use for every future instance of the prefab. Now, in previous versions of my object pools, I was using the name of the prefab, but that leads to several problems that can be solved. But one of the problems that cannot be solved is that there is absolutely no guarantee. There's nothing preventing you from creating prefabs, different prefabs, with the same name. So name is not a unique identifier. That's why I'm using instance ID here. And so I initialize then the instance ID with prefab.poolableID. This is just to simplify. It's just syntactic sugar, just not to always do prefab.poolableID. I don't do prefab.getInstanceID all the time because that, on the other hand, brings a little bit of overhead. So now that we have initialized the poolable ID, let's see if our pools contain, if our dictionary of pool contains a pool that corresponds to that instance ID. If it does, then all I need to do is to say, okay, I have a pool. I just call get object on that pool, and that's going to return me the object that I need, and that corresponds to the prefab that I want to instantiate. If it's not, then we need to create a new one. So first of all, we're going to create the transform in which we're going to group all instances of that object. So we do new game object, and we call it prefab.name plus instance ID. This allows us to have prefabs that are maybe different, but have the same name. And so that's going to be the transform of this new game object that we create. And it's just going to be an empty game object. It's just so that the scene is a little better organized. It serves no real purpose other than not having the scene completely clogged up. So if you want to optimize the game to not have any overhead when doing that. I mean, it's not going to be a big overhead anyways, but yeah, that's a small optimization. I like to have my hierarchy clean when I'm doing some testing. So that's why I do this. It's not a necessary step. Then the next thing we do is, well, we create the new object pool with the prefab and with the group. So then what we can do is add the pool that we just created to our dictionary of pools using the instance ID as a key. And then finally, we can just use that newly created pool to get an object of the specific type we want. And then we return it. So that's the get object. And the pool object now, the pool object is just going to see, hey, does the pool contain, do I have a pool for that object poolable ID? If I do, then I call pool object on the corresponding pool. If I don't, well, this is a design choice. I could say, oh, okay, I don't. I'm being asked to pool an object that was not created by my object pool, because if it was created by my object pool, then it would have already a pool that existed corresponding to its poolable ID. So how could this happen? Well, maybe another object just instantiates by itself without using the pooling system a new prefab. Or it could be also that it was just put on the scene at the start by the level designer. So do we want to pool those kinds of objects is the big question. And I just choose to say no. Anything that's not specifically created by the object pool system is not going to enter the object pool system. And finally, we have a remove method that we can call saying, hey, I want to remove this object, and it's going to find the corresponding pool and tell that pool, hey, that object belongs to you, please remove it. So this is all good and fine. But how do we then use this? Well, this is a singleton, right? Our object pools manager. So that's how the object pools manager is automatically created. But I'm going to go over the singleton anyways very quickly. So this is my singleton here. I allow it to possibly be persistent if you want. There is a static instance. We get that instance. We can get that instance with this get instance method and then call whatever we want on it. And if the instance does not exist, then we create a new object that has that component. And also, what we want to avoid, of course, is to have several instances of our singleton that are put on the scene by someone who doesn't know better and puts like 10 different instances. And we want to make sure that in the end, when the game starts, there's only one single instance that is the instance of our singleton, and all the other ones, they're just getting destroyed. So now last thing is a pooling static class. So the pooling static class contains static methods that allows us to actually forget about the fact that our objects are pooled or not. So are poolable or not. So thus far, my object pools manager, all these method get objects, they take a poolable and they return a poolable. But our canon doesn't really need to know much about the poolable class. What we can do is to say, oh, we want to use pooling, but we don't want to limit ourselves to a poolable projectile. Maybe we can just change this, because if we set poolable here and then you decide, no, I don't want poolables things anymore, well, you're going to lose the reference here, or you remove the poolable from your prefab, and that's going to be a problem if you do that. So instead, we have our canon just have a very standard game object projectile. And we use pooling to get the object. So our pooling system here has a get object method that takes a game object and also a fallback method if the game object is not a poolable. So if I do, so the first thing I do is check, hey, does that game object have a poolable component? If it doesn't, well then I'm going to use my fallback method to instantiate that. And so here I have another signature for get object that doesn't take any parameter and that calls a default object fallback method. And this is just going to instantiate. That's what it's going to do. Same with try pool. So I take a game object here. I see, does it have a poolable? If it doesn't, then I call the fallback method, and that fallback method is just going to destroy the game object. And if we do have a poolable, then we call the object pools manager dot get instance dot pool object poolable. And this is how everything fits together. So now in my cannon, all I have to do is to say, hey, you know, my cannon can shoot projectiles. They can be poolables. They can be maybe non-poolables. Who cares? And in my tree, I have my an object destroyer here, and I have a boolean say, hey, do I want to use pooling or not? This is just for the demonstration purpose, obviously. But so this one just says, okay, if I'm using pooling, then I'm going to try and pool whatever object comes in collision with me. And that's what happened here when I shot with my first cannon. My first cannon shoots, wait, I have to say, so I activate use pooling, but my first cannon shoots a projectile that does not have a poolable. So it's not a poolable projectile, but yet it is completely handled by the pooling system. It is destroyed just normally because it does not have a poolable. But if it does have a poolable, then it is just simply entering the pooling system. And so this is this more advanced version of an object pools manager. Once you have that, well, you can just plug it in any kind of game you want. All you have to do is change your instantiation. Instead of using instantiate, you just do pooling.gameObject, and that's all you have to do. You just get all the other things, and they're already out of the box. Now, the only little thing that's a little bit annoying is that you then have to manually set the transform position, that transform rotation, instead of having it directly in the signature. Now you can change pooling and add all those different signatures of get object method to allow them to have an extra reference to the transform rotation, the transform position, whatever other things you need to have to simplify your life. But that's very trivial. That's why I don't put it in here. But anyways, hope this was interesting for you. Hope it was clear enough. I know I've been pretty fast through all of this, but it does suppose that you already have a good understanding of object pooling. If you don't, I suggest you take a look at some other tutorials. There's plenty of them that are really well made. And then you can just go back on here to see how you can do it a little more advanced. Thanks for watching, and maybe we'll see each other in another video.